Okay, cool. So today the talk of my title is a demo for a data-intensive application and magic behind it. So as the title suggests, I'll separate my talk into two parts. The first one is a demo for a data-intensive application in the logistic field, and then I'll explain the magic behind it. So this talk forms part of the tutorial building a real-time analytics application with TiDB Cloud. So if you're interested, please scan this QR code. Okay, so about myself. So my name is Chenhao. I'm a developer relations specialist here at PingCAP. I received a Ph.D. degree in database from the University of Sydney early this year. Now let's get started. So the objective of this demo is to show that a data-intensive application and how TiDB work with this data-intensive application. So like Li Chuan just explained, TiDB is a HTAP database, and when the column store, when a TiFlash is enabled, OLAP queries can be largely accelerated. Here's a side note here. We don't actually have index. We don't simply put index on the raw store to accelerate things. Instead, we have a totally separate TiFlash node. Cool. Is it frozen? Okay, cool. So high-level overview, the success story of PingExpress demo crop. So why HTAP is important in logistic field? So the reasons are twofold. Firstly, from the customer's perspective, so the customers would like to know where the packages are whenever they order a package from the web. And secondly, from the company's perspective, the management team and the resources allocation team, they would like to understand the situation of the company, find potential bottlenecks, and doing some early actions to make sure the customers get their packages in time. And then why HTAP is challenged in the logistic field. So I've listed a couple of numbers here, and as you can see, these are already pre-pandemic numbers. So you can imagine that nowadays the numbers are skyrocketing. Also, a package in the logistic field has a long life cycle, sometimes 2 days and sometimes even as long as a month. So during all these long life cycle, this record will be queried again and again. That's going to impose extra challenge for the system. Okay, PingExpress is now a supply chain management company in the United States. It grows rapidly in the past 2 years due to the pandemic. Their MySQL backend now is unfortunately not keeping up. So the performance of the standalone machine is poor, and reporting and analytics can be only done over the midnight. That leads to a couple of results. Firstly, the postmen have to deliver in the city like headless chicken, and they have to work overtime. The postmen are exhausted, and the customers are also very unhappy. They suffer from package loss, package delays, etc., etc. And so the PingExpress is now actually Sloss Express. Okay, now PingExpress demo crop would like to make some change. They've now switched to TiDB. So the reasons are twofold. Firstly, TiDB is HTAP database, so it can support OLTP and OLAP queries at the same time. And secondly, it's MySQL compatible, so they don't have to change the code a lot before they can switch to another database. Okay, so here are some background knowledge. So the PingExpress divides the life cycle of a package into 4 stages. In the first stage, the package arrives to the company, and in the second stage, the package arrives at the processing center of the state of origin. And in the third stage, the package arrives the processing center of the destination state. And finally, the package receives to the end user. Here is the table structure of PingExpress demo crop. So PingExpress use a giant white table, and there are a couple of fields in it. Package ID, time, send, courier, receiver, state, and transaction kind. Like I've explained before, we have the PingExpress divides a life cycle of a package into 4 stages. Right, here is the architecture of PingExpress demo crop. So we have TiDB Cloud in the middle. It enables both TiDB and TiFlash. And the OLTP client is deployed on Amazon EC2 So we are mimicking 50 clients, sending requests, sending update requests, as well as inserts to TiDB Cloud. And I also have a Metabase dashboard, which provides real-time reporting on my own laptop. Cool. So if you walk through the whole tutorial by yourself, there will be 3 methods. Execute is the only method we are going to use in the demo today. It's just execute the program, which mimics 50 clients updating the table. We also have load, where you can load your data. You can also use pre-generated data, which is already available on S3. And you can also update to your timestamp. So the pre-generated data was generated like 3 months ago. So if you are doing this tutorial by yourself, you have to move the data, move the timestamp forward to make the dashboard makes more sense. Okay, here are a few major steps in this demo, in this tutorial. So I've done all these previous steps before the demo. So what I'm going to do now is I'm going to first run the OLTP workload and then observe the database, and I will refresh the database and give you an intuition about how long it takes to refresh a database, a dashboard. I'll also show you the execution plan, and then I will disable TiFlash and then repeat the whole experiment to give you a comparison about the speed of refreshing dashboard with or without TiFlash. The reason for first I'll include TiFlash and then disable TiFlash is because disable TiFlash is an asynchronous operation. That means it can finish instantly. However, if you do other way around, you have to wait for some time. Okay, cool. Now the exciting part. So I'm going to first run the program. So I'm going to run this program with 50 clients, not this terminal. Should be, is it this one? Okay. Cool. Cool. Now the program starts running. Let me show you this dashboard. So this is dashboard for PingExpress. It's automatically refreshed once per minute. Okay, let's see these 2 questions firstly. So the 5th question is number of packages per day, the number of new packages comes in the company per day. As you can see, there are around a bit less than 9,000 packages comes in per day. And this is the number of packages in processing. So we have 5 couriers for the company. And courier number 4 has the largest number of packages in processing. If a courier, if the number of packages in processing for one courier exceeds some threshold, then it will be the company can do something to make sure this courier keeps up. Also, this is the number of packages in processing in each state. For example, now Texas has a large number of packages. It may now be a good time for the company to start making phone calls to wake up couriers in Texas. And these 2 questions are pretty straightforward. The first one is total packages delivered so far and number of packages on the way. So you may already realize that the courier number 4, this color here has been turned into red, which makes courier number 4 is not keeping up, and we should actually do something. And also here, the new packages per day just increase. Okay, cool. So I'm now going to refresh this page to give you an intuition about how long it takes to load this page. Okay, refresh. Okay, it took less than 5 seconds. All right, cool. I'm now going to show you the execution plan. We are going to use this query. Copy. Okay, that's on the Web SQL shell of TiDB Cloud. So Web SQL shell enables you to connect to TiDB Cloud just using web page. Okay. Oops, sorry, I've copied it twice. Deleting the duplicated command. Okay, so as you can see now, most of the commands are just going to the TiFlash. That's why it's pretty fast. Okay, so what I'm going to do now is to first place stopping my program. Then I will disable type flash. Alter table package set type flash replica equals 0. Double checking type flash is gone. Okay, cool. So now I'm going to start running the program again and give you a comparison. Okay, program starts running. I'm going to refresh this page again. So it will definitely take a long time this time. Let's just keep waiting. 10 seconds already passed. Okay, still waiting. So in the previous refresh, we took less than 5 seconds, but now it's already 20 seconds passed. 30 seconds passed, still waiting. Yeah, okay. I'm not going to wait any longer. Oh, okay. It finally comes up. So 40 seconds, around 40 seconds. So as you can see, with and without type flash, that's a huge difference. Okay, so we also have dashboard for each user. For example, this is Alice's dashboard. For end user, she can see that there are where her packages are, one in Texas and one in Georgia, and there are 3 packages on the way. Also, she can see all her package history and number of packages she ordered per day. Okay, cool. So it's coming back. I forget to show the execution plan to you without type flash. So let's do it now. Okay, so without type flash, as you can see, all these queries are just hitting TiDB. So that's why the announcement query is a bit slow now. Okay, cool. Getting back to the slides. So after switching to TiDB, Ping Express Demo Crop is becoming a much better company. So the resources allocation team can understand where the bottlenecks are and take actions quickly. So that's making customers more happy. And company can give courier clear instructions on where to go, and more importantly, includes their lunch break. So the employees are happier. And for the company, there are less resources waste. They can save fuel. They can save lots of different resources. So it's a win-win-win situation. Cool. Now, in the second part of my demo, I'm going to explain you the magic behind data-intensive application. So here's the overall architecture of the TiDB. So in TiDB, we have computation layer, which is TiDB and TiSpark. And we have 2 storage layers. The first one is TiDB storage layer, which is a raw store. And we also have TiFlash, which is column store. So we have smart selection algorithm. Whenever a query comes in, it will automatically decide whether to send this query, or even send part of the query to TiDB or TiFlash. That's going to accelerate things a lot. Okay, on this page, I'm going to explain why column store sometimes helps. So I have a working example here. Try to give you intuition about why column store helps. So here's a table: ID, time, sender, destination. And we have a query here trying to find out the number of packages sending to California. So in the raw store, the data are just organized row by row, starting with ID, time, name, destination, and just repeated. However, in the column store, the data from one field, the data from the same field are stored together. So all ID are together, all timestamps are together, people are together, and the destinations are together. So when CPU process these data, it has to fetch the data from the lower level of the storage hierarchy and bring it upwards from the massive from this hard disk to memory to cache. Now, if these data are organized in the raw store, all these data have to be fetched before they can process and find out the destination and find the record Washington. However, in the column store, we only need to have to fetch this small part, this small bit. That means for system, there's less I/O, and that's going to accelerate things. Okay, cool. Now, on these slides, I'm going to compare the traditional solutions with TiDB. So I've just copied this slide from Li Chuan's presentation. So traditionally, what people do is we have multiple systems, sometimes OLTP database, and then do the ETL overnight, put it into data warehouse before they do analysis. So the ETL process is painful, and there's no data freshness for reporting. So it's whenever you have the insights, it's already in the midnight, and that also means high cost for multiple systems. You have to maintain 2 licenses, and you have to maintain 2 groups of engineering time. Okay, finally, what I'm going to do is talking about the data freshness in TiFlash. So actually, TiFlash and TiKV, they forms a Raft group. Raft is a algorithm to keep strong consistency. So here's the data flow in Raft. I mean, it's only data flow. So the data comes from the clients and it sends to the leader. So leader serves all clients' requests and broadcasts the data to the follower and learner. So TiFlash is a follower here. Oh, sorry, TiFlash is a rough learner here. So data is sent to follower and learner. And by the way, learners are non-voting followers. So that's how data fresh is maintained. A working example here. For simplicity, I didn't have the rough follower here. That's only a rough learner, which is TiFlash, and rough leader. So whenever a query comes into TiFlash, it will check with the rough leader whether its data is up to date. Otherwise, it will just keep waiting the log to be replicated to rough learner and applied on the rough learner before reply to the clients. So in this case, you have to wait for a bit longer time, but the data freshness is guaranteed. Okay, cool, wrapping up. So in my talk today, we first see a demo for a data intensive application. We can see that PingExpress, after switching to TiDB, PingExpress can do the OLTP query and OLAP queries at the same time so that they can have some real-time insights. Then we explain the magic behind this data intensive application. So TiDB is a HTAP database, and it uses Raft group to synchronize these data. Okay, cool. So you can also try out this tutorial by yourself by scanning this QR code. It's super fun. And if you want to learn more, you can scan this QR code to read our real world use case studies. Okay, cool. That's everything I would like to say, and thank you very much.